Welcome to MRS Bulletin's Materials News Podcast, providing breakthrough news and interviews with researchers on the hot topics in materials research. My name is Sophia Chen. Humans are using increasing amounts of data every day. We're streaming high-definition movies on our phones, we're exploring the use of the incredibly data-heavy virtual reality, our devices rely on artificial intelligence, which requires huge amounts of data to train. That's why some engineers are looking to the emerging technology of photonics to transmit more information more quickly. Photonics technologies look beyond the voltages and currents in conventional electronics to manipulate light directly. Photonics also aims to use higher frequencies of light, including encoding information in the optical and terahertz range. Conventional electronics tend to use lower frequencies. Xuchen Wang has developed a new type of photonics device for amplifying light signals in future telecom networks.
So if your wave is amplified, your communication efficiency will be improved.
The device has a real sci-fi sounding name. It's called a photonic time crystal. Wang, an applied physicist at Karlsruhe Institute of Technology in Germany, explains the name in analogy with a conventional crystal. A conventional crystal is composed of repeating unit cells in space, such as 8 carbon atoms arranged in a cube to form a diamond. A photonic time crystal, on the other hand, has a structure that repeats in time.
So photonic time crystal is also a periodic structure, but the periodicity, it is not in space, it is in time domain. So it means that the material property is periodically changing in time.
Wang's photonic time crystal is not composed of atoms, but copper structures arranged on a surface. Using conventional printed circuit board technology, he created these structures to look like a forest of mushrooms. The device is a type of metasurface.
In our community, we call it like a mushroom structure. Yeah, it is very commonly used in electromagnetic community.
The mushrooms are on the centimeter scale, around the size of real mushrooms. In between each mushroom, they place a variable capacitor known as a varactor. They can change the varactor's capacitance by applying different voltages to it. To create the photonic time crystal, they apply changing external voltages to the varactor, modulating the material's electromagnetic properties in time. Wang then confirmed experimentally that this device amplified microwave signals that he sent across its surface.
I see the output wave amplitude, it's like amplified a lot.
Researchers had proposed photonic time crystals a few years ago and made theoretical predictions that they should amplify electromagnetic signals. However, these designs consisted of three-dimensional metamaterials whose properties are difficult to manipulate in the laboratory.
It is very difficult to modulate or change the property in time of this three-dimensional structure.
The innovation of Wang and his collaborators was to adapt the three-dimensional time crystal design to a two-dimensional metasurface. It's the first time anyone has experimentally demonstrated a photonic time crystal that can amplify an electromagnetic signal, he says. Wang is working on methods to improve the photonic time crystal to amplify signals more strongly. In addition, one potential application for photonic time crystals is to make a new type of laser that does not require mirrors. Conventional lasers amplify light using mirrors, but Wang says future lasers could incorporate a metasurface-based time crystal to do the amplification instead. This could make for a much more compact design. This work was published in a recent issue of Science Advances. My name is Sophia Chen from the Materials Research Society. For more news, log onto the MRS Bulletin website at mrsbulletin.org and follow us on Twitter @MRSBulletin. Don't miss the next episode of MRS Bulletin Materials News. Subscribe now. Thank you for listening.